In a three-phase system installation with multiple panels fed from a single main breaker, it is incorrect to install bonding straps on both panels. The correct procedure involves several key steps. Firstly, split the grounds and neutrals. In a three-phase system, the grounds and neutrals should not be bonded together in subsequent panels. Instead, a separate ground bar and neutral bar must be installed in each panel. Secondly, bond the grounds only. Connect a bonding strap between the ground bars in both panels. This ensures that all exposed metal surfaces in the electrical system are properly grounded, providing a safe path for fault currents. Thirdly, do not bond the neutrals. The neutrals should not be bonded together in either panel. Instead, they should be connected only to the neutral bar in the main panel. The reasoning behind this is that the 400 amp main breaker provides only overcurrent protection for both panels. It does not merge the two panels into a single electrical system. Installing a bonding strap on the second panel would create a parallel path for neutral current. This can lead to overloading of the neutral conductors and create potential fire hazards due to excessive heat. By splitting the grounds and neutrals, you ensure proper grounding and prevent the neutral system from becoming energized by ground currents. The 400 amp lugs on the second panel are for connecting additional feeders, not for bonding. The bonding strap should only be installed on the main panel where the neutral is connected to ground. It is important to always follow applicable electrical codes such as the National Electrical Code and the manufacturer's instructions when installing electrical panels and related equipment. Correct grounding and bonding are critical for electrical safety and preventing equipment damage. In the main panel, the neutral bar is bonded to the enclosure, typically through a bonding screw or strap. This establishes the connection between the neutral conductor and the grounding system. The ground bar is also connected to the enclosure and, subsequently, to the grounding electrode system such as the grounding rod or water pipe. From the main panel, separate grounding and neutral conductors are run to the subpanel. At the subpanel, the neutral conductor is isolated from the enclosure and connected to the neutral bar. The ground conductor is connected to the ground bar, which is then bonded to the subpanel enclosure. It is essential to maintain the separation of neutral and ground in the subpanel to prevent circulating neutral currents and ensure proper operation of overcurrent protective devices. These devices, such as circuit breakers, rely on a clear path for fault currents to trip and disconnect the circuit. If the neutral and ground are bonded in the subpanel, fault currents may return through multiple paths, potentially reducing the current flow through the intended path and delaying or preventing the overcurrent device from tripping. This can create a hazardous condition. The size of the grounding and bonding conductors must be appropriately sized according to the applicable electrical codes. The grounding conductor must be sized based on the size of the overcurrent protective device protecting the circuit. The bonding conductor must be sized based on the size of the largest ungrounded conductor in the circuit. Proper selection and installation of these conductors are essential for ensuring a low impedance ground fault path. Low impedance ensures that fault currents can quickly and safely return to the source, facilitating the rapid operation of overcurrent protective devices. In addition to the grounding and bonding conductors, other metal components in the electrical system must also be properly bonded. This includes metal conduits, enclosures, and equipment frames. Bonding these components together creates a continuous electrical path, ensuring that any fault currents are safely conducted back to the source. Bonding is typically accomplished using bonding jumpers, which are short lengths of conductor that connect the metal components together. These jumpers must be adequately sized and securely fastened to provide a reliable electrical connection. Regular inspections and maintenance are also important for ensuring the continued effectiveness of the grounding and bonding system. Over time, connections can loosen, conductors can corrode, and equipment can deteriorate. Regular inspections can identify these issues before they become major problems. Maintenance tasks such as tightening connections, cleaning conductors, and replacing damaged equipment can help to maintain the integrity of the grounding and bonding system. It is essential to use appropriate tools and techniques when working with electrical systems. Always to energize circuits before working on them, and use properly insulated tools to prevent electrical shock. Follow all applicable safety procedures and wear appropriate personal protective equipment such as safety glasses and gloves. If you are not comfortable working with electrical systems, it is best to hire a qualified electrician to perform the work. Working with electricity can be dangerous, and it is important to take all necessary precautions to protect yourself and others. In summary, proper grounding and bonding are essential for electrical safety. By following the applicable electrical codes and using appropriate materials and techniques, you can ensure that your electrical system is properly grounded and bonded, protecting people and equipment from electrical hazards. Remember to split grounds and neutrals in subpanels, bond only the grounds, and never bond the neutrals in subpanels. Regular inspections and maintenance are also important for ensuring the continued effectiveness of the grounding and bonding system. Always work safely and follow all applicable safety procedures. If you are unsure about any aspect of electrical work, consult a qualified electrician. They will be able to provide guidance and ensure that the work is done safely and correctly. The grounding electrode system is a critical component of the overall grounding system. It provides a connection to the earth, allowing fault currents to dissipate safely. The grounding electrode system typically consists of one or more grounding electrodes, such as grounding rods, ground plates, or metal water pipes. The grounding electrodes must be installed in accordance with the applicable electrical codes. Grounding rods must be driven into the earth to a specified depth, and ground plates must be buried below the frost line. Metal water pipes must be used as grounding electrodes only if they are in direct contact with the earth for at least 10 feet. The grounding electrode conductor connects the grounding electrode system to the main panel. The grounding electrode conductor must be sized based on the size of the service entrance conductors. It must be installed in a continuous length, without any splices or joints. The grounding electrode conductor must be securely fastened to the grounding electrode system and the main panel. Surge protection devices are also an important part of an electrical system's protection strategy. Surge protection devices protect sensitive electronic equipment from voltage surges caused by lightning strikes, power line disturbances, and other sources. Surge protection devices are typically installed at the main panel and at individual equipment locations. They work by diverting surge currents to ground, preventing them from damaging the connected equipment. It is important to select surge protection devices that are rated for the voltage and current levels of the electrical system. They must be installed in accordance with the manufacturer's instructions and the applicable electrical codes. Regular testing of surge protection devices is also important to ensure that they are functioning properly. Some surge protection devices have indicator lights that show whether they are still working. Others require periodic testing with a surge protection tester. If a surge protection device fails, it must be replaced immediately. Arc fault circuit interrupters are another important safety device that can help to prevent electrical fires. Arc fault circuit interrupters detect arc faults, which are dangerous electrical conditions that can cause fires. Arc faults occur when electricity jumps from one conductor to another, creating heat and sparks. Arc fault circuit interrupters are designed to trip and disconnect the circuit when an arc fault is detected, preventing a fire from starting. Arc fault circuit interrupters are required in many areas of the home, such as bedrooms, living rooms, and dining rooms. They must be installed in accordance with the applicable electrical codes. Regular testing of arc fault circuit interrupters is also important to ensure that they are functioning properly. Arc fault circuit interrupters have a test button that can be pressed to simulate an arc fault. When the test button is pressed, the arc fault circuit interrupter should trip and disconnect the circuit. If the arc fault circuit interrupter does not trip when the test button is pressed, it must be replaced immediately. Ground fault circuit interrupters are another type of safety device that can help to prevent electrical shock. Ground fault circuit interrupters detect ground faults, which occur when electricity leaks to ground. Ground fault circuit interrupters are designed to trip and disconnect the circuit when a ground fault is detected, preventing a person from being shocked. Ground fault circuit interrupters are required in many areas of the home, such as bathrooms, kitchens, and outdoor outlets. They must be installed in accordance with the applicable electrical codes. Regular testing of ground fault circuit interrupters is also important to ensure that they are functioning properly. Ground fault circuit interrupters have a test button that can be pressed to simulate a ground fault. When the test button is pressed, the ground fault circuit interrupter should trip and disconnect the circuit. If the ground fault circuit interrupter does not trip when the test button is pressed, it must be replaced immediately. Electrical panels should be properly labeled to identify the circuits they control. This makes it easier to troubleshoot electrical problems and to turn off the correct circuit when working on electrical equipment. Circuit directory should be updated whenever circuits are added or changed. The electrical panel should be kept clean and free of obstructions. This allows for proper ventilation and makes it easier to inspect the panel for damage. Electrical panels should be inspected regularly for signs of damage such as corrosion, loose wires, or burned components. Any damaged component should be replaced immediately. Electrical work should only be performed by qualified electricians. Working with electricity can be dangerous, and it is important to take all necessary precautions to protect yourself and others. The National Electrical Code, or NEC, is a comprehensive set of standards for electrical wiring and equipment in the United States. The NEC is updated every 3 years, and it is important to stay up to date on the latest requirements. The NEC covers a wide range of topics, including grounding, bonding, overcurrent protection, wiring methods, and equipment installation. The NEC is enforced by local electrical inspectors who ensure that electrical work is performed in accordance with the code. Compliance with the NEC is essential for ensuring electrical safety. Local electrical codes may also have additional requirements beyond those specified in the NEC. It is important to check with your local electrical inspector to determine the specific requirements in your area. Electrical permits are typically required for most electrical work. Permits ensure that the work is inspected by a qualified electrical inspector and that it meets the requirements of the electrical code. Electrical inspections are an important part of the electrical safety process. Electrical inspectors check electrical work to ensure that it is performed in accordance with the electrical code. Inspectors look for things like proper grounding, bonding, overcurrent protection, wiring methods, and equipment installation. If the electrical work does not meet the requirements of the electrical code, the inspector will require that it be corrected. This is called a red tag. Once the corrections have been made, the inspector will re-inspect the work to ensure that it is now in compliance with the code. Only then will the inspector approve the electrical work. When working with electricity, it is important to always follow safe work practices. Firstly, always de-energize circuits before working on them. Use a voltage tester to verify that the circuit is de-energized. Secondly, use properly insulated tools. This will help to protect you from electrical shock. Thirdly, wear appropriate personal protective equipment, such as safety glasses and gloves. Fourthly, never work alone. Have someone nearby who can help you in case of an emergency. Fifthly, be aware of your surroundings. Look for potential hazards such as wet floors or exposed wires. Sixthly, never work on electrical equipment that is wet or damp. Seventhly, never overload circuits. This can cause a fire. Eighthly, never tamper with electrical equipment. This can be dangerous and can damage the equipment. Ninthly, if you are not comfortable working with electricity, hire a qualified electrician to perform the work. In a 120/200 8-volt 3-phase system, the voltage between any two hot legs is 208 volts, while the voltage between any hot leg and the neutral is 120 volts. This configuration is commonly used in commercial and industrial buildings. In a 277/480 volt 3-phase system, the voltage between any two hot legs is 480 volts, while the voltage between any hot leg and the neutral is 277 volts. This configuration is typically used in larger commercial and industrial buildings. The 400 amp breaker protects the entire service from overcurrents. If the total current drawn by all the loads connected to the panels exceeds 400 amps, the breaker will trip, disconnecting the power. Feed-through lugs allow the main panel to feed power to the second panel without the need for additional wiring or connections. The feed-through lugs are connected directly to the 400 amp breaker, providing a direct path for the current to flow to the second panel. A 42-circuit panel has spaces for 42 individual circuit breakers. This allows for a large number of circuits to be connected to the panel, providing power to various loads throughout the building. The information is about grounding, bonding, and safety.